Hello friends, welcome you in my YouTube channel. I am Dr. Mohammad Sirajul Faizi, Assistant Professor, Department of Chemistry, LS College, Muzaffarpur. Today in this video, I am going to explain about physical properties and structure of amines. So you know that amines are moderately polar compounds because of the greater electronegativity of nitrogen relative to carbon and hydrogens. Since 1 degree and 2 degree amines have NH bonds, the hydrogens bonds intermolecularly causing their boiling points to higher than those of alkane of comparable molecular weight but lower than those of similar alcohols. 2 degree amines boil at lower temperature than 1 degree 2 degree, but all amines can hydrogen bond to water, making low molecular weight amine water soluble. So comparisons, you see, this is the alkane methyl cyclohexane, and this is cyclohexylamine, and this is cyclohexanol. If you compare molecular weight, so almost same. Boiling point, you see, huge differences. Amine is less than alcohol. So water solubility insoluble, slightly soluble, and 3.6 gram per 100 milliliters. So friend, now I am going to talk about structure of amines. In this slide you will learn about the structure of amines. So nitrogen atom is most amine is similar to that in ammonia and can be considered to be sp3 hybridized. An unbonding electron pair is in an sp3 orbitals. Look at this molecule. The geometry is described as trigonal pyramidals and bond angles are close to 109. So if you look at here, you know, these portions which is the red is showing the negativity and more electron density is here. So a calculated structure for trimethylamine, the electrostatic potential map shows the charge associated with the nitrogen unshared electrons pair. Now, in this slide, I will talk about the stereochemical features. So, stereochemical features means when there are three or four counting the unshared pair different groups attached to the nitrogens, the structure is a chiral. But because of very fast inversions at the stereocenter, the inversion rate in NH3 is close to 10 to the power 11 per second. It is not possible to resolve chiral amines. So interconversions of amine enantiomers by fast inversions at the nitrogen center. You look at here, this is in equilibrium and very fast. And on another hand, I will talk about the quaternary ammonium salts compound of type R4N plus X minus display stereochemical features. You know that if nitrogen's lone pair of electron involved in donating to another alkane, then it is forming quaternary ammonium salt. So if they contains four different R groups, they are chiral and being a stables. Now I will tell you what is the non-inverting form. Non-inverting form, it is not converting from one form to another form, can be resolved into their enantiomers, right? Now look at here, this conversion is not possible. Now another important point is we talk here, and the chiral quaternary ammonium salt can be resolved. Interconversions of enantiomers would require bond breaking. So this is all about the stereochemical features of amine. Now, in this slide, I will talk about the basicity of amines and amine salt. So, you know the what is the meaning of basic and basicity of amines. We will say the greater the basicity of an amine, the weaker the acidity of its conjugate acid and cation in its salts. So look at these reactions here, RNH3 plus and water. It is under equilibrium and forming RNH2 and plus H3O plus. If you calculate the Ka, so Ka is equal to concentrations of RNH2 and concentration of H3O plus. It is divided by concentrations of RNH3 plus. And what is the relations between pKa and EKa and pKa? pKa is equal to minus, don't forget the minus, minus log Ka. And this is the relations between Ka and pKa, and that is very important. Now we will talk about the influence of alkylations on acidity of ammonium ions. If you look at these molecules here, NH N plus is surrounded by 4 hydrogens and the pKa value is 9.26. If you compare this with CH3 and one hydrogen replaced with the CH3, then you see the increasing of pK value 10.64. Now, if you look at this, I just removed the in place of methyl, I added ethyl, then again little will change after point, so 10.75. These experimentally determined pK values show that alkylations decreases the acidity of these conjugate acids, which means that their parent amine becomes more basic on alkylations. So friends, now come to the another orders, how it is following the orders. If how you compare the carbocations into this to ammonium salt. So this stabilization of positive charge on nitrogen by alkylation is parallel to the stabilizations of carbocation. Look at this is the carbocation, and carbon has positive charge. So it is another examples of electron releasing nature of alkyl groups. If you go through this, you see R is approaching to nitrogens and bonded to nitrogens, and nitrogen has positive charge. This increase in the basicity of an amine by alkylations is slightly enhanced by introductions of a second alkyl groups. Further alkylations of 2-degree amine does further increase basicity, and that is important here. We have to remember it, but only if you measured in the gas phase. In the usual aqueous media, iminium ions from 1 degree and 2 degree amines are very effective, stabilized by the hydrogens bonding with water molecules. Iminium ions from 3 degree amines with only one NH bonds per ion are not as well stabilized. So 3 degree amine in water cannot fully utilize and their true basicity. So what is the conclusions here? Just look at here and you will find a very good relationship between the basicity of primary, secondary and tertiary amine. So order of increasing basicity in gas phase, I'm talking about the gas phase, and that is important word, you have to remember it. So NH3 less than RNH2 less than R2NH, this is primary amine, this is secondary amine, tertiary amine. Now just think about the order of increasing basicity in water. So this is the order of basicity in water, and it is in the gas phase and it is in the water. So what is the difference between gas phase and in water? You look at here, the positions of R3N is changed from this position to this position, and this is the difference between gas phase and basicity in water and in solvents. So now I will talk about the basicity of phenylamines. You see aniline ions, this is the aniline ions, and their pKa value is 5.58, and now this is cyclohexylaminium ions and the pKa value is 10.64. You see the difference here is 4, 5 point and 10.6, and almost just double. The greater acidity of anilinium ion means that aniline is a markedly weaker base than its cyclohexylamine, atypical 1 degree alkyl amines. Now, friend, I am going to focus about the how resonance contributing in this regard. So, decreased basicity of aniline is primarily due to the delocalizations of the unshared pair on electrons by benzene rings. You look at here, this is the aniline, and now you see this lone pair of electrons is taking part in the resonance. So these two general types of benzene resonance forms are the only one available to stabilize the anilinium ion. You see, this is the anilinium ion. So the smaller enthalpy change on protonations of cyclohexylamine, we call it del H. This is, you know, the enthalpy 1. And on the protonations of aniline, we call it enthalpy 2. Results from its net resonance stabilization and explain why alkylamine is more basic than aniline. So look at here, this is your compounds, water, and then you see, and in the same way, if you have this compound aniline and water, you have this. So this del H1 is less energy than this del H2. So what is the del H2 is much greater than del H1. So larger resonance stabilizations of aniline. This is showing, and a smaller resonance stabilization of anilinium ion. And that is important to here discuss why this one is larger and this one is less energy. So less energy means a small resonance stabilization of energy, and this is large energy means large resonance stabilization. So basicity of aryl amines is due to lowered by this p2 hybridized carbon attached to the amino groups. It is more electronegative than the sp3 carbon of an alkyl groups. So friend, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.